Alright. So it's kind of the replacement video for class. We can do it live. We'll go through the same material that we're planning on. So yesterday, we kind of introduced the idea of monopolistically competitive markets. So today I'll kind of start module 13. We'll finish it tomorrow. So we've got the participation quiz that goes along with this video. Tomorrow we'll have one more participation quiz. That'll be the last one. And then we'll also see that module 13 quiz will pop up here tomorrow after class. That'll be the last thing that we have assigned before the final. You've got that module 12 quiz and the two participation, sorry, actually, that one was from last week. The one participation quiz from Monday that'll be due at the end of the day Thursday. Same kind of thing with these two participation quizzes and the module 13 quiz, all due by the end of the day Thursday. And then Friday, we'll kind of have that final exam. So we've got the practice exam already up there. We'll go through that Thursday. You'll see on Friday that, the actual final exam pop up under this category here. Other than that, that should kind of cover all the logistics. We'll kind of dive into the material here. So we started discussing this at the end of last class, but we're going to look at monopolistically competitive markets. And we said, we'll kind of keep going here. Here we go. It's going to be like a mashup of two markets we've already talked about. So we had monopoly markets and perfectly competitive markets. So like perfectly competitive markets, these monopolistically competitive markets will have many, many sellers and many buyers. So nobody has any influence over the price of this good. However, kind of similar to a monopoly, it's not a unique, like they're not the only seller of this good, but their product is slightly differentiated. So this is the idea that, Qdoba and Chipotle are selling burritos, but Chipotle burritos are a little bit different. So they have differentiated products, so they have somewhat of a unique product. So they're going to have some control over the price of their product. However, the idea is that if Qdoba starts to charge $30 for a burrito, everyone's going to just substitute towards that Chipotle burrito, right? They're not different enough to where people won't substitute. So we're also going to have, like a perfectly competitive market, no barriers to entry, and firms can freely enter and exit this market. And that's going to kind of cause some different implications than we would see if this was a true monopoly. Okay. So they've got a differentiated product, right, which is going to give them some market power, not complete market power, but some market power. Okay. They're still going to set that profit maximizing quantity, just like a monopolist and a perfectly competitive market would, where marginal revenue, that last unit where marginal revenue is equal to marginal cost. They're then going to go up to the demand curve. We'll see that the demand curve for them looks a little bit different than a perfectly competitive market. So they'll go up to the demand curve then to set the price, just like a monopolist would. We're going to see some markup. So kind of similar to a monopolist, the price that they set was above their marginal cost. We said with perfectly competitive markets that they took the equilibrium price of that good as given. Price ended up being exactly equal to marginal cost. So we're starting to notice there's some characteristics that look like a monopoly, some that look like a perfectly competitive market. Okay. So we'll first talk about what is the demand curve that a monopolistically competitive market faces. So with a perfectly competitive market, we said their demand curve was simply that equilibrium price. They can't get away with charging anything other than that price. It's a completely homogeneous product, the exact same as everyone else is selling. So if I charge a different price, everybody just buys from someone else. So I've got to charge that equilibrium price. That is my firm's demand curve or the marginal revenue the firm faces. With a monopolist, we had a downward sloping. They faced the entirety of demand. And then they were setting a single price. So the price that they were setting was twice as steep, right? And we kind of went through the formula, taking the derivative to kind of prove why that was the case. What will end up being true about these monopolistically competitive firms is, okay, they're going to face a portion of the overall demand curve. So they're not going to face the entire market demand curve, but just a smaller portion of it. Think about Chipotle gets, a fraction of the overall demand for fast food or fast casual burritos. Now, there are substitutes. So we said slope and elasticity aren't one-to-one, but if there are substitutes, people are going to be more elastic to price changes. There's more things they can substitute away to, as opposed to a monopolist. There was nothing, right? They were the only seller of this exact product. So we're going to have a slightly less steep demand curve, reflecting that demand that the monopolist, the competitive firm faces, isn't quite as elastic. However, they have somewhat of a unique product, And so they're going to set the price for their product based off the portion of demand, overall market demand that they face. So their marginal revenue curve will also be twice as steep. Okay? Just twice as steep as their demand curve, which is a little bit more elastic or a little bit flatter than a monopolist would. Okay? Oops. So if we think about kind of this monopolistically competitive demand, what we're really looking at here is, and we don't often make this comparison, but to kind of give some insight, here would be like the overall market demand that a monopolist would face. Okay. And then their marginal revenue curve would be twice as steep. Okay. I'll draw it in a different color here. So the monopolistically competitive market, so we can kind of think about Chipotle and Qdoba, and let's just say those were the only two sellers. So let's say we have more than two, but just to kind of get this idea down, they're going to only have like a portion of the overall market demand, right? Some people are going to want to buy a Chipotle burrito. Some people want a Qdoba burrito. So they're only going to get a fraction of the demand curve, right? So their demand curve is going to start at a point that's lower than overall market demand. And it's going to be flatter because people can substitute away from their product, right? Now, they're still going to face a twice as steep marginal revenue curve, okay? So if we were to try to kind of compare a monopolist to a perfectly competitive market, we can think about, let's say they faced the same costs. So their marginal costs were the same. We can think about, let's just for a second assume that they're the only seller in this market. If this was a monopolist, marginal cost would be equal to marginal revenue at this quantity. They would go up to the demand curve to then set their price. For the monopolistically competitive market, they face only a fraction of that market demand. So even if they face the exact same marginal cost a monopolist did, their marginal revenue is equal to marginal cost at a lower quantity. And that's going to be the case if we only face a portion of demand. It's almost like we're facing a smaller, lower leftward shift in that demand curve. They then go up to the demand curve to set their price. Okay. Now, kind of allude to this a little bit here. I might come back and draw another visual of this, but to kind of give some insights here, because that demand curve that the monopolist faces is twice as steep, we can kind of think about what is the difference between price and marginal cost here. Give myself some space to write over here. This would be like the markup of the monopolist. Okay. Now, we notice is because it's not as steep, what's the difference between, and we're at a lower quantity, what's the difference between the price the monopolistically competitive firm chooses and their marginal cost? Well, notice this markup, I try to draw this to scale, is a little bit smaller, right? It's a little bit smaller than a monopolist would have. So the price that a monopolistically competitive market is going to choose is going to be less than the monopolist. The quantity they choose to maximize profits would be less than the monopolist. And what will also be true here is the markup that we see from these monopolistically competitive firms is going to be smaller than the markup that the monopolist would choose. Okay. However, if we were just looking at the monopolistically competitive firm's demand curve, it looks very similar to how we were solving these monopoly market models, right? It's just that if we're comparing the two, they're facing a lower, kind of smaller portion of overall demand. And so the price and quantity they set are going to be lower, and their markup is going to be lower as well. Everything's lower. That's an easy way to kind of remember it here for the monopolistically competitive markets if we're comparing them to a monopolist. Okay. Actually, I think I'm probably jumping the gun here, but I think based off what I've talked about, let's go through this first as well before we think about profits for these monopolistically competitive markets. If I was instead thinking about, okay, I've got the demand curve that these monopolistically competitive markets are choosing, and I've got their, marginal revenue curve as well. Okay. They then have some increasing marginal costs, right? And I can think about they choose the quantity, or marginal revenue is equal to marginal cost. They then go up to their demand curve to set that price. Okay. So what if instead we thought about, let's say we had, this was the demand. If this was a perfectly competitive market, marginal cost should represent the supply curve. So where would the supply curve hit our demand curve? That's where we said the market equilibrium would be for a perfectly competitive market. So if this firm was acting as though this was a perfectly competitive market, they're not going to make decisions based off a twice as steep marginal revenue curve. We would see the equilibrium point be where the supply was equal to the demand. So what's going to end up being true? The perfectly competitive market is going to choose a lower price. However, because there's no market power, we end up at that perfectly competitive quantity, right? And then we don't have a markup to compare because what is the marginal cost and the price for a monopolistically competitive firm? It's exactly the same. So if we wanted to, what's the marginal cost of a monopolistically competitive firm? It'd be down here, right? At that quantity, this is their marginal cost. What's the marginal cost? Well, it's exactly the same as the price for a perfectly competitive firm. So the markup, because there is some markup for a monopolistically competitive firm, and the markup for a perfectly competitive firm is 0, the markup for the monopolistic competitive firm will be a little bit larger. And we'll think about deadweight loss here in a second, but just kind of comparing those prices and quantities and the markups for a monopolistic competitive firm to a monopolist, we said that would always be the price, quantity, and markup would be lower. If we're comparing it to a perfectly competitive market, the price, quantity, actually, sorry, I'm writing in that. The price is going to be what? Higher. Quantity here, I drew my arrow the wrong way. The quantity is actually going to be larger in this perfectly competitive market. And then the markup will also be larger for a monopolistic competitive market relative to a perfectly competitive market. Okay. So that's kind of comparing to the markets that we've already talked about. We'll now start to think about, okay, if we have this monopolistically competitive market, what are profits going to look like? Okay. So let's say they face this downward sloping demand curve, twice as steep marginal revenue curve, which means that at every quantity, wherever the marginal cost hits marginal revenue, when we go up to the demand curve to set the price, price will always be above our marginal revenue. Okay. So if I drew in there an average total cost curve that looks something like this, when they choose that profit maximizing quantity, marginal cost is equal to marginal revenue down here. They then go up to the demand curve to set the price. At that quantity, the price, or how much money they're making per unit, is above their per unit cost, or their average total cost curve. So just like we had before, how do I calculate profits? It's the quantity the firm sells times the difference between their price and average total costs. So here I've got positive profits. Okay. Now this can occur in the short run, but if there are positive profits, if firms can freely enter and exit, what's going to happen? Just like the perfectly competitive market, we said if positive profits exist, firms will start to enter that market. Okay. Now, what if, and I'll kind of show you what would happen in the long run here in a second, what if instead the current demand that these monopolistic competitive firms face is lower? Well, now the quantity where marginal revenue is equal to marginal cost, we go up to the demand curve to set the price. Now my price is below average total cost. Still finding that optimal profit maximizing quantity where marginal revenue is equal to marginal cost. But when the price is below average total cost, now my profits would be negative. All I can do is minimize my losses here. Now, if there's negative profits, what will firms do in the long run? Exit this market. Okay. So in the short run, we kind of have two possible options for the monopolistic competitive firms: operate with positive profits or operate with negative profits. Okay. If profits are negative, well, should I stay open or should I shut down? They face the same shutdown decision that a perfectly competitive firm would. So we said, what's our shutdown decision? Well, if we want to stay open and minimize losses or shut down, what did we say we look at? The price relative to our average variable costs. Okay. So if I ended up in a scenario like this, where, okay, here's my current demand, marginal revenue. The profit maximizing quantity is where marginal revenue is equal to marginal cost. I go up to the demand curve to set my price. Notice the firm still has a markup. The price they're setting is still above their marginal costs. However, that price is below at that quantity what their average total costs are. So even though we have a markup, my profits, price being below average total cost, would still be negative. So just kind of as a reminder, where that's coming from is we said our profits are equal to the quantity we're selling times the difference between price and average total cost. So if price is ever below average total cost, we know profits here, positive times a negative value, would be negative. If price is ever above our average total cost of that profit maximizing quantity, there we had profits being positive. But if profits are negative, we said we have another decision to make, which is if price is above average variable cost, we should stay open. Our profits from staying open will be greater than our profits from shutting down. So, and what were our profits if we shut down? Remember, that would just be negative, whatever our fixed costs are. If price ever falls below average variable costs, well, there our profits from staying open should now be less than the profits if we simply shut down, right? And we'd actually be better just paying our fixed costs and leaving that market. Okay. So in the slides, the depiction we had here, what is the value of my profits? The difference between price and average total cost times the quantity I'm selling. Well, what is this area here? The difference between average total and average variable costs is simply my average fixed. If I take my average fixed costs, multiply it by quantity, that would just be my fixed cost. So this smaller rectangle would represent negative profits if I simply shut down. Okay. So because that price is below average variable, the profits from staying open, or this larger rectangle, as soon as price is below average variable, it'll always be larger than the profits if I just shut down, which would be this rectangle here representing just my negative fixed costs. Okay. So give a little bit more insight into this. Try to kind of write this out in a slightly different way. Hopefully it'll help. So let's say I've got my demand curve, twice as steep marginal revenue curve, got my marginal costs, I've got average total costs, and I've got my average variable costs. Okay. So at that profit maximizing quantity, here's the price that they set. So price is below my average total. So I know that profits are going to be negative, right? I can kind of think about if I were to stay open, my profits are the quantity I'm selling times that difference between price and average total cost. Okay. So it'd be like this entire rectangle here. Another way of writing this is if I kind of rewrite, so I've got quantity times price minus average total costs are my average variable plus my average fixed. I'm going to rewrite this a little bit to be price minus average variable. Quantity times my average fixed would just be negative fixed costs. So notice, anytime price is above average variable, my profits from staying open, this will be a positive value, and I actually will have profits that are greater than just losing my fixed costs. Anytime price falls below average variable, this is going to be another negative value. I'd actually be minimizing my losses if I just shut down, right? So anytime we have price fall below my average variable costs. Staying open would generate larger negative values than if I simply shut down. Okay. Now, where are my fixed costs represented in this graph? Well, if I just take the difference between average total and average variable costs, so average total minus average variable, this would give me my average fixed. That's what this is looking at. If I take the quantity I'm producing, average fixed times the quantity I'm producing would just give me my fixed costs. So that's why this rectangle here simply represented my profits if I shut down, which would just be negative whatever my fixed costs are. So they follow the same rule a perfectly competitive market would. As soon as that price falls below average variable, I'm better off just shutting down. Okay. And that's kind of what we had depicted here. Okay. Now, what if instead I had an example like this? So I'm now thinking about, okay, where is the profit maximizing quantity? It's where marginal revenue is equal to marginal cost. So that's going to be right here. I then go up to the demand curve to set that price. Now notice here, price is still below my average total cost. So my profits, the difference between price and average total cost times the quantity I'm producing, still be negative. However, if I shut down, what would my profits be? Well, my average fixed cost is the difference between average total and average variable. So if I take my average fixed costs, multiply them by the quantity, oops, no, do I have it here? No, there we go. That's not what I wanted. I'll draw this out for us. I thought I had it in the slides, but I didn't. So before I draw this out, actually, let me kind of say this. So my profits are negative. Because that price is above average variable, it should be that by staying open, this negative profit value is better than the profits if I simply shut down. So to kind of give you a visualization of that, if I'm thinking about I've got a demand curve here, twice as steep marginal revenue. Here's the marginal cost the firm faces. Whoops. Let's say here's their average total cost. And here's their average variable cost. Okay. At that profit maximizing quantity, where marginal revenue is equal to marginal cost, they then go up to the demand curve to kind of set their price. Well, price is below the average total cost here. So my profits, if I stay open, would be the quantity I'm selling times the difference between price and average total cost, right? That would be this area here. If I shut down, we said, what are our profits? It should simply be negative whatever our fixed costs are, or another way of writing that was negative if I've got the quantity I'm selling times the difference between my average total and average variable costs. And then I know that those will be negative. I shut down, I'm just paying whatever my fixed costs are. So notice here, what's the difference between the average total and the average variable? Well, that, if I shut down, my losses would actually be a larger rectangle or an even larger value. So anytime the price they set is above average variable costs, shutting down would actually generate larger losses, so they should stay open. Okay. All right. So kind of very similar decisions that the perfectly competitive market is making in terms of, do we have negative profits or positive profits? If we have negative profits, we shut down if price is ever below average variable cost at the profit maximizing quantity. We stay open to minimize losses if that price is ever above our average variable costs. Okay. All right. What do I want to say here? Yeah, it's just a different way. I drew this out for us here. But you kind of think about if the price ever is below average variable, if I stay open, my profits are this entire area. If I shut down, We said fixed costs are just the average fixed cost times quantity. What is my average fixed? Difference between average total, average variable. So here, notice my loss is if I shut down, a smaller area than my loss is if I stay open. So anytime price falls below that average variable cost, the firm is better off just shutting down. Okay. Let's see where we're at here. Could do advertising. We'll say firm entry and exit, I think. Let's think if there's anything else I want to say here. I think that should be good. Oh, I'll make one point. So let's say we were in the long run. I just want to kind of rehash or revisit this idea. What happens to the difference between my average total and average variable cost? So in the long run, I can turn everything, nothing is fixed, everything is variable. So in the long run, my average total cost is my average variable cost. So if I think about a scenario here where the price was above average variable, in the short run, they will operate with negative profits to minimize their losses. However, over time, what happens? I start to change things. Everything that was fixed becomes variable. So my average total cost would be equal to my average variable cost. So in the long run, we don't have a difference between those two curves. So if we ever had a scenario where in the short run, given the demand curve that the monopolistically competitive firm faces, if they're choosing a quantity where marginal revenue is equal to marginal cost, and the price they're setting is here, even though their average, even if their average variable cost in the short run was down here, in the long run, their average variable cost becomes the average total cost. So in the long run, what is my shutdown decision? Well, in the short run, it was as long as that price, if that price ever falls below average variable, that was where we said we shut down. Well, notice in the long run, average total is equal to average variable. So in the long run, if price is below my average total costs, so this was like short run, in the long run, if price falls below average total, essentially that's saying it is below my average variable. So in the long run, even though the firm might operate here in the short run with like negative profits, in the long run, we know they would just shut down or exit the market. Okay. So thinking about the long run, I don't have any difference between my average total and average variable cost curves. Okay. All right. So let's think about if these firms are advertising. Okay. So it's going to get a little bit tricky here because we have two things going on if firms choose to advertise. Okay. So if I think about Chipotle and Qdoba, or even like think about different bottles of water, they're differentiated product. Even if it is the same product, I can convince consumers my bottled water is way better than everybody else's. In theory, it's practice, it's probably all the same, right? It's, I don't know. I could probably bottle tap water and sell it for the same price as, Aquafina or whatever it is. And so if I can convince people that my product is more differentiated, I'll be able to get a larger markup, right? And we'll kind of see what this looks like here in a second, okay? So the more differentiated the products, right, it makes a little bit more sense for firms to buy advertising because I want consumers to know my product is different. If I can convince them my product is different, I can get more monopoly power. My markup is going to increase, okay? So we've got some disagreement about the value of advertising, and we'll kind of walk through why, right? So the critiques of it would be, you're just wasting resources. The product is what it is. All you're doing is spending more money, right? And then that's just increasing average total costs. It's not going to change the actual demand curve or the marginal benefits to consumers, okay? So you could also argue it's convincing consumers that their marginal benefit is something different than what it is. We won't really dive into the modeling that, but that would be a good critique. And then also, if we have advertising, potentially, what did we talk about with a perfectly competitive firm relative to monopolistically competitive firm? So if we went back, we said, oh yeah, the monopolistically competitive firm is going to charge a higher price and choose a lower quantity we won't get to that allocated efficient market, or sorry, allocated efficient outcome of an allocated efficient, perfectly competitive market. And so we're going to actually generate some deadweight loss potentially, right? Even if this is the exact same product, if we convince consumers that it isn't, we give firms some monopolistically competitive power, we're not going to end up at that point where total surplus is maximized, okay? So what is this going to kind of look like? So we can walk through what advertising or branding would do, right? So I'm going to draw it out into two different graphs, and then we'll think about the kind of combinations of the two. Okay. So let's assume for a second that I can somehow advertise and it costs me no money. So I don't know what this would look like. You can think of, like I think the example like Ted Turner. He owned a broadcast company. So if he wanted to create some other products and advertise on his own network, maybe it wouldn't cost him anything. Now there's opportunity cost there, but just for this really weird scenario, let's assume I can somehow advertise and it costs me nothing. So it doesn't change my cost curves. Okay. So originally, my demand curve, and I'll kind of make an extreme example here, might look something like this for the monopolistically competitive market. Okay. So here, marginal revenue would equal marginal cost at this quantity. We go up here to then set the price. Notice the difference between price and marginal cost here, pretty small markup. Okay. Now, price is way below my average total cost. So if we were calculating profits here, they would be negative. Well, if through advertising, if it was completely free, I can convince consumers that my product is even better, right, than all the other ones, what I could end up with is a larger portion of the overall demand curve. So if I can get a larger portion of the overall demand curve, I'm facing a higher demand curve. Now, also through advertising, if I can convince consumers that my product is more dissimilar to other ones, so I can convince everyone my bottled water is better, they're going to be more inelastic. So not only can I get a larger portion of the overall demand curve, right? So just as a kind of reminder, this is like the demand curve the firm faces. So this would be like Chipotle. This is how much people want to buy their burritos, but there's an overall market demand just for burritos in general. Okay? Well, now notice here, I've got not just a larger portion, but a more elastic. I've convinced consumers my product is more differentiated. I've got a twice as steep marginal revenue curve. Now notice at this quantity, right, after advertising, and I tried to draw this to really make this point, the price the firm sets, notice here, it's exactly equal to their average total cost. So I started out here, price was below average total, my profits were negative. After advertising, now my profits are zero. So what have I done? Through advertising, I've increased the price, I've increased the quantity I'm selling, and if profits were negative and now they're zero, I've increased my profits. You can imagine a different scenario where I, get an even larger portion of overall demand. I could eventually push my profits to be positive. Okay. All right. So here is kind of the effects of getting a larger portion of the overall demand curve, or even just changing that slope of the demand curve to be a little bit more steep. And I'll revisit this in just a second as well to kind of show you what if only one of those things happens. So we've got this going on here. I'm going to kind of leave this to the side. So yes, advertising will have these impacts on, I can get a larger portion of the overall demand curve. However, what is it also going to do? So let's say I've got my marginal costs, got my average total cost curve here. What do I want to draw to make this point? So let's say the other extreme. So I've got, here's demand, here's my twice as steep marginal revenue. Okay. Originally, if I was selling this quantity, I go up to the demand curve to set the price. Price is above, oh, not here. Price is above my average total. It's also above my average or my marginal cost. So I have a markup. But if price is above average total, this would represent profits that are positive. Okay. So we can kind of combine what we talked about last class with this. So if there's the incentive for one firm to advertise, right? They can increase their profits. What do you think every firm does? Every firm advertises, it offsets each other. So if by spending money in advertising, if everybody's spending money, my demand curve wouldn't shift. What have I done? So this was kind of thinking about the positive impacts of advertising. Let's assume the other extreme, which is I spend money in advertising, everybody else does. There's no shift in my demand curve. I get the same portion of the overall market demand. But what have I done by spending more money on advertising? You can think of really advertising is this large fixed amount. So I spend an amount of money on it regardless of how much I produce. So what has happened? Well, I haven't changed my marginal costs. So the quantity that the firm chooses is still the same. The price they set is still the same. But if I've increased my fixed cost, this huge amount of money spent on advertising, notice what is now true in this second scenario. Now price is below average total costs. And what has the firm done? They've now created negative profits. So price potentially could stay the same. Quantity could stay the same. If I'm not changing my marginal cost, I'm just changing my average total. But I've decreased my profits. And this gets even more amplified if those costs somehow are, right? If my advertisement is somehow linked to quantity. So even if I shift my marginal cost, but the probably more accurate way of thinking about it is that we really wouldn't see a shift in market. It's more likely that these advertisement is just increasing my average total costs. Okay. So what's the ultimate effect going to be from advertising? Well, even if I can get a larger portion of overall demand, notice that's going to increase my profits, but spending money in advertising wouldn't. So really it's going to be this trade-off. Am I getting a larger portion of the overall demand curve that's going to more than compensate me for these additional costs? And that's kind of intuitive, right? I only want to spend money on advertising if the gains that I see from getting a larger portion of the overall demand curve are greater than the decrease in profits from having this increased cost. The problem is, once again, what's probably more likely the scenario in the real world, everybody has this incentive to advertise to get a larger portion of overall demand. So if everybody's spending more money on advertising, what have we done? We're not getting any different portion of demand because it equally offsets each other. We've just increased our costs. And so advertising kind of ends up with this prisoner's dilemma, which is that we're all spending money on advertising. Demand is still being split the same, but we've increased our cost and decreased our profits. Okay. So just kind of thinking about advertising, thinking about shifts in the demand that a firm can get, but also the shifts in their costs. Okay. All right. I just wanted to point out one more thing here, and let me make sure. I think I covered what I wanted to. Oh, that's not what I wanted to do. There we go. So, there we are. All right. So the defensive advertising, right, is this idea that, maybe it's providing useful information to buyers, allowing them to kind of a more competitive market if we know the prices that exist, differences across firms. So maybe it can reduce market power, get us closer to these perfectly competitive markets. So that would be kind of the defense or the benefits. So there was a study that was kind of interesting. So states where eyeglasses were more expensive there were states that had laws in the books that prohibited advertising. So consumers weren't aware of the price differences and they actually ended up paying higher prices. So there might be some benefit to having advertisement in terms of consumers are able to find different prices, or essentially advertising eliminates monopoly power, right? So if there's no advertising, I don't know that there's exists other firms I can buy from. It's essentially giving firms that I'm aware of more monopoly power. Okay. All right. Let me think here. Kind of already worked through all of this. This is just kind of summarizing. I don't want to go to the long run yet. So do want to go through one more thing with advertising just to kind of think about what's going on. So let's assume, so I've got a firm, here's their marginal costs, here's the demand curve that they face, here's their twice as steep marginal revenue curve. I'm going to try to draw this out. Here's their average total cost. Well, this was supposed to be at its minimum point, right? But I was looking at this weird. Okay, so I got my average total cost. So they choose where marginal revenue is equal to marginal cost. They go up, set the price up here. It's equal to their average total cost. So profits originally were equal to 0. Okay. Notice if I didn't even change the elasticity of the demand curve, if I start out where, whoa, profits are 0, any increase in my demand curve, like even if it's a parallel shift, so the one I drew out earlier wasn't parallel. So let's say the same substitutes exist. I haven't made my product more or less elastic. However, I've gotten a larger portion of the overall demand curve. So I just wanted to kind of make this point that even if I get a larger portion of the overall demand curve, but I haven't changed the elasticity of that demand curve, right? It still has kind of that same slope. What are the implications here? Anytime I see a demand increase, right? So they're able to get a larger portion of the overall demand, that's going to increase the quantity the monopolistically competitive market or monopolistically competitive firm chooses. When they go up to that demand curve, that price is now going to be higher than it was before. And as long as I can get a larger portion of demand without spending any additional money, the price is now above my average total cost, so I should also be increasing my profits. Okay. Now we said if in order to get that larger portion of demand, I had to spend more money, well, what could happen there if I had to spend more money? So here's like my second average total cost curve. Well, now notice price is exactly equal to my average total cost. So I would still get that the quantity and price go up, but it's possible if in order to get a higher portion of demand, I also had to spend more money to do so, we could get back to this point where profits are exactly the same as before. They could be higher, they could be lower, right? We don't know what's going to happen to profits if, in order to get that higher portion of overall demand, we had to spend some additional money, right? Increase our average total cost curve. Okay. Let me think where we're at here, what I want to say for tomorrow. So we can do all the long run. Yeah, we can do all this stuff tomorrow. What else do I want to do here with advertising? Oops. Nope, I want to go here. There we are. So there's two more things that I want to think about today in terms of advertising and also monopolistically competitive firms. So if I think about, well, I don't want to confuse you too much. So we'll just do one more thing, right? So let's assume we're thinking about a perfectly competitive market, and we want to compare this to monopolistically competitive monopolies or perfectly competitive markets. So the easier one I think originally we'll start out with is, let's assume, so I've got my average total cost curve, I've got my marginal cost curve, which intersects it at its minimum point. Let's think about a scenario where so I've got my firm's demand and their twice as steep marginal revenue curve. Okay. So they're going to choose this quantity where marginal cost is equal to marginal revenue. Up here is where they'll go to the demand curve to set the price. Price is exactly equal to the average total cost. So the profits of this monopolistically competitive market are zero in what I have drawn here. Okay. Well, no, I want to hold on. I want to make this point even more. So let me, I wasn't paying attention when I was doing. I need to make sure that this, here we go. So I'll draw my demand curve in first so I make sure that I'm not hitting this wrong. So we got marginal revenue and demand of the monopolistically competitive market. Here I've got, what do I want? Here's my monopoly or my marginal costs. And we'll give them positive profits just to kind of make this point. Well, lights turned off. So if I'm thinking about the monopolistically competitive firm, marginal revenue is equal to marginal cost here. They go up to the demand curve here to set the price. Notice initially price is just barely above average total costs. So they would have some positive amount of profits here. Okay. So in the short run, if this is the quantity they're choosing, where would a perfectly competitive firm choose to be? Well, they wouldn't face this downward sloping demand curve, right? They would just be taking that market price, that equivalent price is given. Or if we think about marginal cost as representing the supply curve, they would be at the point where supply is equal to demand. So these perfectly competitive firms, they're going to be at a lower price, we said, but at a higher quantity. Well, notice what is total surplus in this market? Well, consumer surplus is the difference between the price they're paying and the area below their demand curve. And then producer surplus, the area below the price they're charging, but above their supply curve. Well, the monopolistically competitive market stops at this lower quantity. So what surplus is lost? It's the difference between our supply and our demand curve for all of these units that the monopolistically competitive market isn't producing. So just like with monopolies, monopolistically competitive firms are actually going to generate some deadweight loss. Okay. And what we'll actually end up seeing being true is even if profits are equal to zero for the monopolistically competitive firm, right? Those profits are going to end up, even if those profits are zero, those that deadweight loss will still exist. Okay. So with these monopolistic competitive firms, they don't have complete market power like a monopolist would, but they are going to have some monopoly power. And so they're going to generate some deadweight loss. Okay. All right. Let me think what else I want to do here. So not worrying about deadweight loss for a second. The other thing I wanted to do is compare this to kind of thinking about a monopolist. So the monopolist faces all of market demand, twice as steep marginal revenue curve. Let's say their marginal costs are right here. Okay. So notice the quantity that they would choose and the price they would choose results in this deadweight loss. Okay. Now, if this was a monopolistically competitive firm, we said they're only going to face a smaller portion of demand, and there's more firms producing this product, so demand is going to be a little bit more inelastic, or a little bit more elastic. So the monopolist will have a more inelastic demand curve. So it would look something like this. So here's our demand curve for the monopolistically competitive market. Here would be our marginal revenue curve. We said they are going to choose a lower quantity. The price they charge will be lower as well. But kind of notice in this model, where would the perfectly competitive market be? Where would that supply be equal to demand? Notice the deadweight loss generated from a monopolistically competitive firm is going to be much less than if they were acting like a monopolist. Okay. So we can kind of think about, intuitively why. Well, they just have less market power, right? They're going to have less market power than a monopolist would, and so they're going to generate less deadweight loss than that monopolist. Okay. So another kind of comparison of those two markets. So I think what we'll do here is save all of this long run stuff for tomorrow's class. So we'll go through firm entry, firm exit, kind of where our long run equilibrium is. We'll kind of revisit this idea of advertising and brand names. Excuse me. I'll probably work through a few more examples that look similar to what we did today, but in the long run as opposed to the short run where we sometimes have positive or negative profits. So we'll save that for tomorrow. But I want to, in this video, still work through the participation quiz questions from today. So let's say, let's go to the preview here. So let's say we've got this depiction of a monopolistically competitive firm. What is the optimal price and quantity going to be for this firm to choose? Okay. When we're looking at something like this, it should look identical or the same as what we were doing for monopolies. We're going to find the profit maximizing quantity where marginal revenue is equal to marginal cost. So where does my marginal cost curve hit marginal revenue? That's at a quantity of, so these are jumps of 2, so 6. What price does the firm choose? Well, they at that quantity go up to their demand curve, so they'd be setting a price at $12, right? So a quantity of 6, price of 12 should be our answer there. Okay. Now, what would profits be for this firm? Okay. So I've got kind of a similar depiction here. What would the value of profits be if this firm was profit maximizing? Well, I kind of drew in an additional curve here to make this maybe a little more complicated. But we still have that profit maximizing quantity where marginal revenue is equal to marginal cost is at 6. At that quantity, the price I'm setting is 12. Is that above or below my average total cost? Well, it's below. So I know that profits will be negative. So hopefully right here, I rule out these positive answers right away. Okay. If at this quantity, my price is below average total cost, how do I find my profits? Right? So we said, if I stay open, my profits are the quantity that I'm selling times the difference between my price and average total cost. So we said the quantity was 6. Price, am I remembering this correctly? I think it was 12. So if we went up to the demand curve, yeah, price was 12, but my average total cost at that quantity was 14. Right? So my profits here would actually be what? Negative 12, if I'm doing math in my head correct there. All right, so they should stay open and their profits would be negative 12. Now, an additional question I could ask here, right? Or if things were a little bit different, or let's think about if that price, why should I stay open? Well, price is above my average variable cost at that quantity of 6, right? 12 is above, what would this be, 9? So I can think about, well, what would my profits be if I shut down? So if I shut down, what are my profits? We said if I shut down, my profits should simply be negative fixed costs. Another way of writing that is the quantity I'm selling times the average fixed costs. Another way of writing that, how do I find my average fixed? That's average total minus my average variable. Okay. So I'm going to look at this quantity of 6, and I say, okay, the average variable cost is 9. The average total cost was 14. Okay. So if I go ahead and average total cost was 14, average variable was 9 at that quantity of 6. If I do this math, what do I end up finding? This is what? Negative 30 would be my profits if I shut down. So where are my profits maximized, or where am I minimizing my losses? By staying open and producing a quantity of 6. Okay. And I can prove that to myself if I calculate my profits from staying open versus I calculate my profits from shutting down. Okay. Any questions? Any questions? I'm recording this without people watching. So I don't know, kind of just using this to kind of talk, amplify some of those things that we talked about. Let's say I wanted to calculate the deadweight loss that exists in this market. So if that was an additional question I had, what would my deadweight loss be? Well, I know that the quantity of the monopolistically competitive market choosing is 6. What would the perfectly competitive market choose? They get out to this point where the marginal cost or the firm's supply curve is equal to the firm's demand curve. So they would be out at a quantity here of 9. So what is my deadweight loss? It's from all of these units I'm not producing from 6 to 9, that difference between the demand curve and my marginal costs. Okay. So give you a depiction of this. What is deadweight loss always going to be if I'm looking at these monopolistic competitive firms? It's going to look pretty similar to a monopolist. Right? So if I've got quantity, got my demand curve, I got my twice as steep marginal revenue curve, and I've got my upward sloping marginal cost curve. Okay? So notice, if this is the quantity the monopolistically competitive market chooses, where marginal revenue is equal to marginal cost, they go up to the demand curve to set the price. Okay. We said the perfectly competitive firm would choose where the firm's marginal cost or the firm's supply curve is equal to that firm's demand curve. So what is this deadweight loss always going to be? Well, it's all these units that we're not producing. So the difference between the competitive, perfectly competitive quantity and the monopolistically competitive quantity, that's the base of my triangle. What will the height of my triangle always be? It's always going to be the difference between the price and the marginal cost of that monopolistically competitive firm. So we said before this was going to be 9. This was 6. We set a price of 12. What is the marginal cost of the monopolistically competitive firm at that quantity of 6? Right here, it was going to be 4. So we would plug in 4. And it's the area of a triangle, right? We have a linear demand and marginal cost curve. So we then always multiply by 1/2. Okay. This isn't a 9, just to be clear, this is a 4. So really, if we've identified a lot of these things, the deadweight loss will always be the difference between the price and the marginal cost of the monopolistic competitive firm. What does this represent? Earlier, we were calling this the markup. Whatever the markup of the firm is, times the number of units that they're not producing relative to a perfectly competitive market, and then it's the area of a triangle since we have linear demand and marginal cost, so times 1/2. Okay. All right. So I threw in some kind of additional questions there we could think about in addition to these participation quiz questions, but we had -12, and then the quantity of 6 and 12 being kind of the easier questions than the ones that I kind of worked through off of the screen. Okay. All right, so that's going to cover it for the first half of Module 13. Tomorrow, we'll pick up kind of where it is. There we go, where we left off. So we kind of discussed the impacts of advertising, kind of thinking about how we would visualize that or draw that into our models. We'll think about how these monopolistic competitive markets move towards the long run and what that looks like. So I already kind of alluded to a little bit. It looks like perfectly competitive markets where we have positive profits, firms enter, negative profits, firms exit. It's going to look a little bit different than a perfectly competitive market. So we'll work through all of that tomorrow, finish up Module 13. And my guess is we're going to have more than enough time. We'll get through these end slides pretty quick. We're going to have more than enough time tomorrow to then start working through those practice exam questions. Now, if you do have more questions like over practice problems from Module 13, I'll probably field whoever is there live, like to answer the questions that people have. So we can go over practice problems from Module 12, Module 13, or any of the practice final questions. But like I said, I think we probably should have a decent amount of time to do that tomorrow after we finish up Module 13. Okay? So I apologize for not being able to have kind of the live version of this lecture today, but we got through everything that we would have in that live lecture. One more day of new material, and really that'll only probably be like the first half of the class, the next half of tomorrow's class, and then Thursday we'll just be doing review for that final exam, which is on Friday. Okay, so the end is near. We're getting there. Make sure you get on and get that participation quiz answered by the end of the day Thursday. Other than that, I will see you tomorrow.